we could submit our telescope proposals and begin observing, we need to find out a few things first. We need to decide which object we'd like to observe, which telescope we want to use, and how long we need to observe the object. So I picked out 3 different types of objects that I think are the most interesting. If you stick with these for your telescope proposal, you're guaranteed to get a stunning astronomical image. So the 3 types that I'm going to talk about are star clusters, nebulae, and galaxies. Okay, so let's have a look at star clusters first. Now these are groups of stars in space that are gravitationally bound together. They're stars that were born from the same cloud of gas and dust at the same time, and they come in 2 main types. So we have open clusters that are generally smaller, include less stars, and they're not as tightly bound together. And then we have globular clusters that are in general much larger, can contain thousands or even millions of stars, and they're more tightly bound together. In general, globular clusters are quite old. They can be millions, if not billions of years old, and they contain a lot of cooler red stars. The next object we'll look at are nebulae. So these are clouds of cosmic gas and dust that are found in space. So not only do nebulae create beautiful images, because these objects come in all shapes and sizes and all different colours, but they're also very interesting objects. There are 2 main types of nebulae: the star-forming nebulae, where new stars are forming out of this cosmic gas and dust, and then there are nebulae that are created when stars die and they throw all that gas and dust back into space. And finally, galaxies are giant collections of stars, planets, moons, asteroids, star clusters, nebulae, black holes, supernovae. Anything that you can think of in space will more than likely be found inside of a galaxy. Of course, we live inside of a galaxy. Our galaxy is called the Milky Way, and there are billions of other galaxies out there in the universe. And not only are they very interesting, but they also come in a range of shapes and sizes that make some really stunning images. Okay, so once you know which type of object you'd like to observe, you can go to free planetarium software Stellarium, and you can search through the entire night sky to find a specific object that catches your interest. I created a tutorial on how to use Stellarium. On there you will find all of the information you need to fill out your telescope proposal. Specifically, we need to know the type of object, the name of the object, the size of the object, and the magnitude or the brightness. This will tell us which telescope we need to use and how long we need to observe that object for. So let's look at size first. Cumbres Observatory has 23 telescopes, and these come in 3 different sizes. There's 2 of the largest, which are 2 meters, and the others are 1 meters and 40 centimeters. Now each of these telescopes have different uses, but for us we're mainly going to focus on their field of view. Each of these 3 telescopes have a different size field of view. So for example, the 2 meter telescope has a 10 by 10 arc minute field of view. Arc minutes is just a unit that we use to measure size in space. So that's quite a small field of view and wouldn't be suitable for a large object. Whereas if we look at the 40 centimeter and 1 meter field of view, they're much larger and more suitable for observing large nearby objects. So the final thing we're going to look at is the exposure time for our object, and this is how long the shutters on the telescope stay open, gathering light. So the fainter the object, the longer the exposure time should be. Now you can find the brightness of your object on Stellarium. It will be written as magnitude. Magnitude is just the way that we describe brightness when we're talking about astronomical objects. And it's a little bit counterintuitive in that the lower the magnitude, the brighter the object. So for example, the full moon is the brightest object in our night sky, and that has a magnitude of minus 12.9. So we have to be a little bit careful when we're choosing exposure time. We want to make sure not to underexpose or overexpose our object. For example, if we underexpose an object, it means that we didn't collect enough light from that object, and we can end up missing out a lot of details from that object. If we overexpose an object, it means we set the exposure time too long and gathered too much light. We can end up oversaturating our image and just seeing big white blobs instead of the small details of the object. Now don't worry, to make this easier for you, we have put some recommended exposure times on the telescope proposal. All you need to do is find the magnitude for your object and compare it against the recommendations we have. You should now have all of the information you need to fill in your telescope proposal. You can find an editable PDF by clicking the link below. Open this up in any PDF reader and you should be able to type directly onto the document. Again, you can watch our guide on how to use Stellarium to choose an astronomical object and find all the details you need about it. And once you've completed your telescope proposal, share it with us on Twitter or give it to your teacher to share with us, and we'll be picking our favourite telescope proposal and carrying out those observations. I look forward to seeing your telescope proposal, and I'll see you next time.